Alright, this video is going to be about finding polynomials from zeros, and there's a couple of different things that can happen. So the first thing is we can know that the zeros are just two real numbers, or any number of real numbers. This process would be the same. So if that's the case, then what I want to do is find the factors. So if x equals 3 is a 0, then x minus 3 must have been a factor. And if x equals -2 is a 0, then x plus 2 should have been a factor. Now, I'm going to find one polynomial. It's actually possible that either of those factors is multiplied by any real number. And so there's actually an infinite number of polynomials for which this is true. I'm just going to find the simplest, most basic one, I guess. So the next thing that I want to do is I want to actually write my function. So I'm going to call it f of x. And it's going to be equal to the product of the factors. So the quantity x minus 3 times the quantity x plus 2. And then this one hopefully is something you're familiar with. So I'm going to expand, so x squared plus 2x minus 3x and then minus 6. I usually do this in my head, and it's totally okay if you do it in your head. Actually, I'd prefer if you do it in your head. X squared minus x minus 6. So that's one function for which this is true. I could multiply that by any real number and it would still have the same zeros. So that's an issue that'll come up sometimes, so be on the lookout for it. Let's try another one. So this one's a little different. So the zeros are going to be x equals 1 plus radical 3. And x equals 1 minus radical 3. Now, it's a property that if x equals a plus radical b is a 0 of a polynomial, then x equals a minus radical b will also be a 0. So sometimes a question will be a little tricky where they'll only give you one of these two, and you have to know that the other one is also going to be a 0. But it's the same process. So I'm going to find the factors. So the factors are x minus the quantity 1 plus radical 3, and x minus the quantity 1 minus radical 3. And to find the function, which I'm going to call f of x again, it's going to be just going to multiply these factors. So that's essentially what you always do, is you find the factors and then you multiply the factors to get back to the polynomial. At this point, I'm going to make kind of an observation. I see that both of these things have an x minus 1, so I'm going to say a is equal to x minus 1, and b is equal to radical 3. And if you do that, the thing that we have here is actually just the quantity a minus b times the quantity a plus b. And I know that that's going to be a squared minus b squared. So I'm going to use that, and I do this all the time with this type of problem. I'm going to use that to expand this. So f of x is actually just going to be the quantity x minus 1 squared minus the quantity radical 3 squared. And so I can expand that. And if I expand that, I'm going to get x squared minus 2x plus 1, and then minus the square of radical 3, which is 3. So f of x is going to be x squared minus 2x and minus 2. So not so bad. Let's take a look at another one. So in this case, the zeros are x equals 2 plus I, x equals 2 minus I, and x equals 3. So complex zeros are also going to come in conjugate pairs. So if 2 plus I is a 0, then you know that 2 minus I is also a 0. So be on the lookout for that. Let's write our factors. So it's x minus the quantity 2 plus I, x minus the quantity 2 minus I, and x minus 3. So let's write our function in most factored form. So what I'm doing here is I'm kind of colorizing this because I'm going to use that a squared minus b squared property again. So you'll hopefully recall that the quantity a plus b times a minus b is a squared minus b squared. And let's expand this. So I'm throwing parentheses around that. So I'm going to square that. So x minus 2 squared is x squared, and then minus 4x, and then plus 4. And then minus I squared, and then all that times the quantity x minus 3. Keep going. Remember, I squared is negative 1. So it becomes x squared minus 4x plus 5 times the quantity x minus 3. Now I'm going to use the distributive property. So x squared times everything, negative 4x times everything, and then positive 5 times everything. And then just collect like terms. So I get x cubed minus 7x squared plus 17x minus 15. That's my function, f of x. But remember, there's an infinite number of functions. Any real number times this would give the same exact zeros. So let's summarize things you should know. So a couple of useful things. There are actually 4 of them that I'm going to highlight here. So if a plus radical b is a 0, then you know that a minus radical b is also a 0. A second thing, which looks almost identical, it's for complex roots. So if a plus bi is a 0, then so is a minus bi. And then these two properties that I use, one of them I actually didn't use, but I should have, is the quantity a plus b times the quantity a minus b is going to be a squared minus b squared. And the other property is this one, which is well worth knowing. The quantity a plus bi times the quantity a minus bi is equal to a squared plus b squared. So that's definitely worth knowing. I could have used it on the previous problem, but I wanted to just kind of show you that even if you don't know that, as long as you know that I squared is -1, you'll be fine. So that's a couple of examples, and I hope you found this helpful. Good luck.